Hey guys, it's Miss Harper. I just wanted to make a quick note video over some of the review problems that we've been seeing here in our first week of school. Just as a little refresher, most of the stuff you should have learned already in 8th grade, so hopefully it's a refresher, but if you need to review a little bit on this stuff, now is your chance. Feel free to pause this note video and write down any of the information you see. All right, we're going to start by going here on number 1. So as we approach a two-step equation, we want to remember that we use inverse operations to solve these. So remember that an equation is something that has an equal sign. So as we undo these problems, we want to use opposite or inverse operations. Couple things that we've talked about using in class. So first, looking at number 1. Alright, if it's helpful for you to draw that line, you may do so. And I always tell my students to cover up your variable, whatever is attached to your variable, kind of ignore him first and think, who do we need to get away from the 9x? And that would be the positive 10. So first thing I'm going to do to move this 10 across the equal sign is I'm going to use opposite operations. The opposite of a positive 10 is a negative 10. Alright, my 9x is going to drop down. This becomes 0, and that equals negative 26 minus 10, which is negative 36. Alright, and as we work through these, I've been making you guys read these statements out loud. So let's read this. This says 9 times some number equals negative 36. So it's important that we understand what operation is happening here. 9 times some number equals negative 36. So it would be the opposite of multiplying something by 9. Well, that would be to divide by 9. 9 divided by 9 gives us the 1x we're looking for, and negative 36 divided by 9 is negative 4. Alright, remember we're not done until we plug our answer back in to check. Alright, it's as easy as just doing that in your calculator. So I will do 9, and using my parentheses wherever I have an x, I'm going to replace it with the x value that I think it is. So I think x should equal negative 4. So if I input it and I do 9 times negative 4 plus 10, if I did this correct, it should equal negative 26. In which case it is, then I can go ahead and box my final answer. And I know that's right. Alright, let's look at number 2. Okay, I have some number divided by 3 minus 2 equals 3. So again, ignore whatever is attached wherever your x variable is. Ignore him for just a second and think, who do we need to move away from that x variable? And that would be this negative 2. The opposite of a negative 2 is a positive 2. So I'm going to add 2 to both sides. And this goes to 0. My x divided by 3 drops down, and I get 5 over here. Now again, practice reading those statements to yourself. Something divided by 3 equals 5. What is the opposite of dividing something by 3? Whoops. Well, that would be to multiply by 3. So I multiply this side by 3, and whatever I do to one side, I have to do to the other. This gives me 3x divided by 3, which simplifies to 1x equals 15. And again, I'm going to check myself before I wreck myself, and I'm going to hope that whenever I plug in the 15 in place of my x, something divided by 3, minus 2 should equal 3. And then I can box my final answer and feel confident knowing that I got that right. On our last problem here, don't be afraid of that fraction, because now in high school we have these nice handy dandy calculators. So again, cover up wherever your variable is. We want to move any addition or subtraction away from our variable. So we're going to get rid of this 6 by subtracting him to both sides. I end up with 3/4 times some number equals 9. 3/4 times some number equals 9. Well, what's the opposite of multiplying by 3/4? And that would be dividing by 3/4. As I say in class, it looks ugly on paper, but it's the same exact process that we did up here, how we got rid of that 9. Since the 9 was being multiplied by the x, we undid it by dividing. So we can do the same thing with our fractions. And it's really easy because we just do it in our calculators. 9 divided by alpha y equals 3/4. 9 divided by 3/4. And we would get x equals 12. All right, and then again, don't forget, it's really important and so helpful that we make sure that we are plugging our final answers back in. So I can say 3/4 times x, which I think is 12, plus 6, and that equals 15. So therefore, I know it's the correct answer. All right, so why don't you go ahead and look at this problem. Don't be afraid of the fraction. Pause the note video in just a second, work through it, and whenever you resume, I'm going to have the steps shown, and hopefully you got the right answer. Ready, go. All right, if you're coming back on, I hope that you were able to find that x was equal to -16. A couple common mistakes that I see happen in a problem like this is, one, students will oftentimes add 13 here, but remember, this is already a positive 13, and the opposite of that positive 13 is a negative 13. The second common mistake that I see is this. This is a -3/2. Remember that the sign out in front of a number, not only is it an addition or subtraction sign, but it represents the value of a number. So that's a -3/2. So once I get to this step, I need to divide both sides by -3/2, and I did that in my calculator. And 24 divided by -3/2 is -16. And again, you should know that you got the right answer if you had plugged that back in. All right, let's check out our next bit. This part is about the combining like terms. So this is pretty easy. We had a great time doing this in class. All right, we simplify expressions by combining like terms. So notice that with our expression, we do not have an equal sign. So we do not use inverse operations. Instead, we just combine things as they are. So I like to box or underline my like terms, things that are the same. So I have 4x squareds here. And then I have another positive 6x squareds here. I have positive 4 and positive 6. That totals to positive 10x squareds. My next set of like terms are these. I have -2x's and -5x's. It's like you lost $2, then you lost $5 more. How many dollars did you lose? And the answer would be -7x. Now you have two ways of doing this in your calculator. You could say -2 minus 5, or you could say -2 plus -5. And either way you get -7, so whichever way makes most sense to you. Remember that another way you could write this answer would be -7x plus 10x squared. And those are equivalent expressions because they both contain a positive 10x squared and they both contain a -7x. Our last example is right here. Same thing. I'm going to combine things that are the same. So I have -3 xy's and I have positive 2 xy's. So how many total xy's do I have? Well, if I'm not sure, I can just plug them into my calculator. -3 and a positive 2 equals a -1 xy. All right, a lot of students will say, well, a lot of students will ask me, can I write my answer like this? -1 xy, and yes, you can because those two things are equivalent. All right, for my next set of like terms, I have positive 4 and -7. 4 minus 7, or 4 plus -7, is -3 n's. -3n. And again, remember you could write this as -3n minus 1 xy, and those are equivalent expressions. So again, you have another practice problem right here for you to try. Go ahead and give it your best shot. And whenever you unpause your video, I will have the correct answer shown. Ready, go. All right, if you're coming back with me, hopefully you're able to get one of these two answers. All right, negative 4x squared and negative 9x squared, those combine to a total of negative 13x squared. Positive 5y minus 10y, that combines to negative 5y's. Remember that you could write your answer in the opposite way. These guys are equivalent because they both have negative 5y's and they both have negative 13x squared. I hope this helps. Don't forget to like and subscribe.